recording this all over again because I said something stupid. Ignore that. Then like it doesn't exist. So in mechanics we have scalars, vectors. Scalar, like you don't even need to know this. You already do. Scalar, vectors, blah blah blah, magnitude. If you had a graph, with an arrow, Pythagoras to calculate magnitude, which is the same as just doing modulus of the variable or whatever it would be called. And then angle, it's just the argument thing, same as -1 y and x. Then in vectors it's the same, so this is your resulting magnitude, which is the same as resolving the components, or getting the resulting component. Let's say we were 5 meters per second north, whoops, and we were moving 2 meters per second. Not south. South is too easy. Actually, we'll start with south. South. You just subtract them. You also just draw a diagram to represent it. So obviously, this is a bigger error, so you know you're going to get a positive number in this direction. I mean, you know it's going to be 3 meters per second. Up. But let's say instead, they weren't as nice, and they said you weren't moving north. You were moving. You're moving. Start with east. Could represent it again with some arrows. This to me just looks like a triangle. We're going this, triangle, triangle, this angle, or the other way to just use Pythagoras. 5, 2, 5 squared plus 2 squared is 29. There's our resulting magnitude, which is approximately where is approximately 20. 5 point. Yeah, I'll take it. Anyways, you get some random number. Besides the point, this is also what they would consider nice. Now let's say they're not so nice. They say you're not moving 2 meters east, you're moving 2 meters southeast. They've probably done this a while ago. We've got 5 meters up this way. We've got you've done bearings before, you obviously know this 90 plus 5, which is 130 degrees. 5 meters per second and 2 meters per second. So this would be 1 over 2. Nope, that's the wrong formula. 5 squared plus 2 squared. It's just 29. Take away 2bc, so that'd be 10 cos 135, which is just minus 2 root 2, I think. So that'd be 29 take 10 cos 135, which gave me 29 plus or minus, just plus in this case, 5 root 1 something. I didn't square root, and I also deleted it. The lovely calculator. Okay. Approximately, terrible, close enough. 6.0051. Then if you want to do the argument or something, this will just be the 135 degrees, or in the other way, it'd be I and J haven't done for mechanics yet, but it hasn't really changed to be honest. This is also too nice a question. They get really weird. I don't really know. Maybe you'll have 1, 2, 3, then they like calculate the resulting component or something. But it doesn't get too much worse to be honest. Oh, but they could say, okay, we have no, knew too much stuff. They say you have a ball traveling instantaneously at a 25 meters per second. And it is traveling at 25 meters per second northeast. Calculate the horizontal component. Well, they'll be like calculate the distance, the displacement. But to do that, you need the horizontal component. Like, let me make an actual question, so I'm not just waffling. Okay. 25 second minus 1, northeast. Calculate the distance traveled after 10 seconds. Or in 10 seconds. Considering friction, all of those stuff is negligible. There's no air resistance either, although that wouldn't really make too much difference in the particle that we're simulating here. That'd be moving like this. Seconds. If we want to calculate the horizontal distance covered, which is just the displacement, S over T, so we need S, horizontal. T doesn't change because, well, if it did, there'll be a problem. But this would just be resolving. We wanted this. To find this, we just use cos. So it'd be cos 25, which is approximately. I did this earlier. Why didn't I do it? Cos 25 just gives you cos 25 degrees gives you something strange. Why did I get that? Cos 90 obviously 0. I forgot to multiply. I'm a muppet. Okay. 25. And then the angle itself is 45. What am I saying? This is 45 degrees. It's just 25 root 2 over 2. I'll leave it in this form for now because it becomes a bit annoying when you have to use the ugly surd. But just for context, approximately 17 point something. You'll know the answer is generally right when it matches up with your initial resolve component or resulting component. It should always be less. If it's more, you've made a mistake. That's just physics. That can't change. Next, we need to do distance equals speed of time. Speed equals distance over time, sorry. This would be 17 point blah blah blah. Or we could use be 25 blah blah blah, blah times 2 times 10, so this is just 25 times 5 root 2, which is our distance in meters, which is approximately, in mechanics they usually just let you do this for some reason, it's approximately 176.77 meters. Adds up. It's 25 times 10 is 250. which would be the greatest distance in it multiplied by those two vectors. Okay, yeah, that makes sense. Although this doesn't work for equations where you have air resistance involved or you have gravity involved. Let's say we want to calculate the peak vertical distance. We would use SUVAT. I don't like writing this. Basically try and do it in my head if possible. This is redundant for us. Like we don't need it. We want to find out this. We have this. It's just 25 meters per second. Well, no, we need to resolve it. This is just okay, 25 sine 45, which gives you some random other thing. I'll just leave it like that. And our final should be 0 because we want to find the highest point. It's going like this. Whoops. We want to find this. If you think about it carefully, the ball's going to do this. It's going to come back down, up and down. And at one point, its velocity vertically will just stop. Like it'll be 0. Its horizontal velocity won't change, but its vertical will go like woo. You can see it stops going up. It stops completely, and then it goes back down. Physics. So we're able to just estimate this. Acceleration minus 9.81 meters per second squared. And our time, total time, we know is 10 seconds. So if we cut that in half, it would be 5 seconds. Because we know one half, the other half. Okay. There's multiple ways to do this because do that. I'll just use an equation like v squared take u squared over 2vs. If we substitute, we have initial 25 sine 5 squared. We know this is 0, so there's no point. We could technically write 0 squared over 2 times acceleration, which is minus 19.62 in this case. These negatives cancel out. Then we're just left with this. When you put in your calculator, you get squared over 2. Okay. 15. 7. Okay. We have an answer. Simple. One key tip is to always draw a diagram, then just model it. Like modeling in Pure hasn't changed. We found out turning point and one of the roots was this. So close. And this. What else is there in mechanics? Oh, we've already done a slope problem. We have not done a slope problem. Ooh. Okay, give me a sec. Okay, so blah 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 blah. Let's give you a problem with this. This is some of the worst problems you can ever get, as they're so repetitive. I'm actually drawing my slope correctly as well, so you have no excuses. Anyways, we have theta. I'll give you actual numbers, 25 degrees. And let's say the slope is meters. Why would I do that? 10-meter slope. And we have this cool looking Cybertruck thing. Okay. We have a truck going up the slope 25 meters. Calculate. Can't do that one yet. I'll give you a normal one. Calculate the height of the slope given. Um, this is obviously just 10, 9, 25 degrees, which would give you approximately 8. This is a guess. This is a wild guess. I calculated the wrong thing. Wait, if you did cos, I was actually really close. Okay, I'll take it. Um, and cos. No, wait, we're working out the height. Yeah, fine. Okay. 10 sine 25 approximately equals 4 point something meters. Um, okay. That doesn't change. Let's say we want to calculate the distance traveled horizontally, and was 5, which is approximately equals 9. That doesn't change either. What does change, however, is when you're given forces acting on the object on the slope. Let's say this truck. Truck weighs, or it has a mass 25. That's not a truck. What kind of truck weighs 25 kilograms? Let's say it's a toy truck. Okay, toy truck. That has a weight of 2 kilograms. Well, mass of 2 kilograms. Note that I said mass and not weight. You obviously know that weight equals mass times gravity. So if we want to calculate on the slope, it would be W G, which is equal to 9.81 times 2, 19. Also in mechanics, you will use 9.8, which you can just reference as 9.81. You can use either, to be honest. They probably preferred 9.8 because why not? So here we have the weight acting down on the slope, sort of. We have the weight as a whole, but we need to resolve it into its vertical and horizontal components, which is where it becomes more complicated. So if we want to calculate the force acting down, this arrow this way, without driving, let's say this is stationary, the force acting down would resolve it. So triangle, okay, cos. Yeah, cos. Uh, might be sine. It's sine, for goodness sake. Okay, not meters. Uh, Newtons? Newton kilograms? I don't know. And weight. And weight on the slope. Okay. There we go. Okay. Let's say it's moving upwards and it's total driving force, and we have the weight going down. Okay, that's too difficult as well. Let's say it moves up, going in this direction, the steady speed, 5 meters. At the end of the slope, it reaches a speed of 4 meters per second. Calculate acceleration between the point P and point Q. So let's do that once again. I'm not even going to draw it out this time because you know what to do. S equals. We can link initial and final in this case. So it would be 4. Nope. Two times. No, we're working out acceleration. Whoops. 2 times distance. Let's say it's halfway in between, so that'd be halfway in between this point on the slope. Bear in mind. Halfway here. 5 times 2, which is just 10 again, equal to 16 to 25. That'll be minus 9 over 10. I can't be bothered. Meters per second minus 2. Never 10. I'm a muppet. Why wouldn't I just. There we go. This stupid answer. Calculated the acceleration. Let's say we want to calculate the acceleration vertically for whatever reason. You would factor in gravity if we were to do that. Well, we did factor it in here, so you would have to factor in gravity again. So minus 9.81 down. Yeah. I think the hardest thing you'll ever get is when you have driving force on a slope of an object, and you need to calculate friction going in this direction along with the weight component to calculate that driving force. To show you what it would be like, let's say we have the weight going down, which we calculated. This is 8.3 newtons. We have a driving force, let's say, of don't want to do anything harsh, so 12 kilonewtons. That's average. Calculate the friction of the slope. Resultant force is this equals this plus this. So therefore we can say 12 kilonewtons equals mg sine theta, which was the weight going down, which came out as approximately 8.3 newtons plus the mysterious force friction. So this kilonewtons take away blah 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 equals friction. Believe we need to calculate some other stuff. But you get the idea, like it just do. Other than that, in mechanics, there's not much else that gets really difficult. There's pulleys. Everyone hates pulleys. We have angle here, and you have tension. Let's say it was 9 kg. Also under the influence of gravity. Let's say this was, what on earth? Okay, I wouldn't even give you this angle, theta. Calculate the tension on each rope. Let's say for starters we have a rope here. This would just be 9 times 9.81. Because that's just how it works. You'll learn it soon. Let's say we had 2 separate ropes of theta. Theta, you want sine theta, I think. So we're doing all over 2 sine theta of 99.81 over 2. I did something stupid. Yep, there we go. Okay. Let's also say we had an object sitting here. That had a weight acting down, that's including gravity, of 4 kilograms. calculate the moment around this acting this way. Let's say it's not equilibrium, so the moment would be the difference from here. Let's say this was 2 meters. 2 times 4, 8 Newton meters. And then you can also calculate the excess force on one of the strings because it'll be leaning this way. So it'll probably be like a 50 bit here. So that might be maybe 45, 35, 85. Okay. 1/3 the weight on this ring, 1/3 on this ring, or 2/3 on this ring because it's closer. Wouldn't be carrying as much because it'd be a horizontal component. Yeah, gets a lot worse, but it'll also be easy for you because I've just briefly explained. Other than that, done. No more physics of mechanics for the day.